Okay guys, I know that you can't see me, but hopefully you can hear my voice, alright? I'm going to take you through our notes today. I'm going to fill them out right along with you guys and kind of expand on some things that I really need you to understand, okay? So, the whole point of this note sheet, you can read in the black bar up here, is it says, I can plot and interpret a distance time graph. I know that the slope of a distance time graph is speed. I know that a curve on a distance time graph is acceleration, okay? So those second two sentences are really important, alright? And we'll talk more about those in just a second, but that is our objective for this first side of our page, okay? A position time graph can tell us quite a bit of information. Whether a line is horizontal, steep, not as steep, or curved, they all have a meaning for an object's motion. Check out these 4 zombies doing different things, okay? So we have 4 different lines here, 4 different zombies. Now, this side of our notes is only for distance time graphs, okay? You'll see later that we have other types of graphs that we're going to be learning about, but everything on this page is just for distance time graphs, okay? Keep that in mind as we are going through this. Alright, the first thing that I want to tell you guys is that our x-axis, so this bottom point right here, is the starting point or the origin, okay? So our x-axis is the starting point, okay? This is also referred to as the origin. Alright, so what that means is that all of these zombies have like a starting point, like a starting line, the origin, alright, and that's going to be the x-axis. Okay, the x-axis is also going to tell us time, the y-axis is our distance, so how much they traveled and things like that. Okay, now all of these lines are going towards the right, so this line is going that direction, this one's coming here, okay, they're all pointing this way to the right, alright? So we're going to talk about what each of these individual lines are. So this one is line A, okay? This black box tells us, I'll put a letter here as well. That's line A. This one that's going straight across is B. We have C that's going up, and then we have D that's going up even steeper than C is. Okay, so those are our 4 lines. We're going to talk about over here on the right what these lines mean on a distance time graph. Okay, so let's talk about line A first. So line A is the only one that's going down. It's going towards the origin. Alright, so that's what we're going to put on A. A is moving toward the origin. Alright, if we look at B, so B, if we have numbers right here and say that this was at 10, B is staying at distance 10. It's not going up, it's not going down. So it's basically staying in the same spot. Okay? Time is elapsing and B is not moving. They're maintaining the same distance. So we can say that B is at rest because they're not going anywhere. Their distance isn't changing, time is just going and they're just standing there. Alright? So straight lines on a distance time graph tell us that that object is at rest. Okay? In this case, our zombie B is at rest. Alright? And then we're going to talk about C and D together. Alright? They're both going up. Okay? They're changing distances as the time goes. Alright? But D is a little bit steeper. Alright? Now for us, that tells us that D is moving quickly because it has the steepest line. C is moving slower than D, okay? So we don't know, we can calculate the speed later, but if we're just looking at this, D is moving faster than C, okay? So that's how we would describe all of those lines if we were asked what was going on. Okay? So now let's answer some of these questions about what's actually happening. Okay? So it says, who started furthest from the origin? So this is the origin, X is the origin. The line furthest away is A. Okay? So A started furthest from the origin. Who started closest to origin? So closest to the x-axis over here is line C. Who moved the fastest? Okay, so that's going to be the steepest line, and the steepest line is D. So fastest equals steepest. Okay, and who is the slowest? Well, B isn't moving at all, so B is our slowest zombie in this particular graph. Okay? Now, you've heard of slope before, okay? Slope is the slope of your line, alright? So B doesn't have a slope at all. A, D, and C all have slopes. Okay? So what a slope means on the distance time graph, okay, we're going to put a star by this. Slope equals speed. Okay? The slope of a line gives us the speed, and we'll do math for that in just 1 second. Alright. Now, we have another distance time graph. Okay? Remember, all this front page is about distance time graphs. So let's see what's going on in this scenario. Alright? We have A line, we have a B, C, D, and an E line. Okay, you notice E isn't straight, it's kind of more of a curve. We'll talk about that in just 1 second. Okay? So, what's happening in each section? A is steeper than B. Okay, so we're going to say that A is the line that's moving quickly. Okay, so A is moving quickly. B is moving but not as quick as A, so we're going to say moving slower than A. Alright. C, we have a flat line. Okay, the distance is not changing, so C is at rest. Any straight line on a distance time graph is going to be at rest. Alright, and then D, remember our x-axis is the origin. Okay, is this x-axis right here, all of this is the origin. D is moving towards the origin, we're going to say returning to origin. Okay, now E is a new one. Okay, E is a curved line. And if you remember, one of our objectives up here, it said, I know that a curve, sorry, let me get my camera figured out here. Okay, so right up here it says, I know that a curve on a distance time graph is acceleration. Okay, and that's exactly what is happening on E down here. Sorry you guys, there we go. Okay, so E right down here is a curved line. Alright, so whenever we talk about what's happening on E, we're going to say acceleration. Because a curved line resembles acceleration. Remember, all that acceleration is a change in speed. Okay, it's not constant speed, so A has a constant speed. It's going the same speed the whole time. E, you can tell that it's kind of slow, and then speeds up. So that change in speed, that curve, tells us that E is accelerating. They are not traveling at the same rate. Okay? So, front page is all about distance time graphs. Alright? And that's one type of graph. Now, if you flip your notes to the back, we have a whole other type of graph that we need to talk about. Okay? Let me get it situated here really quick. Fix my camera. There we go. Okay, so on the back side of our notes, we have speed time graphs. Okay, not distance time. We are now looking at speed time graphs. So it's going to be different information. Okay? Our objective on this is that I can describe and interpret motion using a speed time graph. I know the slope of a speed time graph is acceleration. Okay? Speed time graphs can also convey quite a bit of information about the movement of an object. A line can be horizontal or diagonal. You will not see curved lines on a speed time graph. Okay? So, speed time graph, let's talk about what's happening each of these lines. Okay? A is a line that's going right across the origin. Alright? And we have B, C, D, and E. Okay? Once again, these are all traveling like to the right. Okay? So like our arrows would be facing this way. Alright? On speed time graphs, alright, the x-axis is going to represent zero speed, or what we have been saying, at rest. Okay, so speed time graphs, now the x-axis is representing zero speed, so there's not a change in speed. They're at rest, they're not going anywhere. Okay, so at line A, we're going to say that they are at rest because they're right along that x-axis, and the x-axis represents at rest. Okay, B, remember now every line that is not straight, every diagonal line is acceleration. Okay, because it says up here in the black box, I know the slope of a speed time graph is acceleration. Okay, so if we talk about this, E is accelerating a lot faster than B is. Okay, so E has a very high acceleration. B is accelerating, just not at the rate that E is. Okay, so we're going to say that B is accelerating slower than E. Okay, E is accelerating quickly. Alright, now, C is going down, okay, and over here we have speed, so this is a high speed, and then it's going down to lower speeds, then C is slowing down, okay, so C is slowing down, or we can say that it is decelerating instead of accelerating. Okay, slowing down. D is a straight line, okay, but it's not on the x-axis. Only the x-axis for a speed time graph is at rest. D is just maintaining its constant speed. Okay, it's a straight line, not on the x-axis, okay? It has a constant speed because it's a straight line, so D is constant speed. Okay? Now, let's look at some examples of some speed time graphs down here at the bottom of our notes, and let's see what we can say about them. Let me lift up my camera just a little bit. Alright, so we have example A, and then we have example B. And as you can tell, there's only one line. This one is starting off straight and then goes up. This one on example B is straight, down, and straight. So we're going to talk about what each of those movements mean. Okay? So, this one says a werewolf cheerleader moves as shown in the graph above. Make up a story to explain her movement. So, we can say that she has two movements. She has this first movement, which is a straight line, and then she has this second movement, which is a diagonal line going up. Okay? So, These are speed time graphs, so we're going to use the information at the top of this page. Alright, so on number 1, movement 1 right here, okay, it's a straight line. Remember, it's not on the x-axis, so it's kind of like D up here, and D is constant speed. So at movement 1, the cheerleader has constant speed. At movement 2, it's a straight line going up, alright, so she's accelerating. Every slope on a speed time graph is acceleration. So on number 2, we can just say that she is accelerating. Okay? Now, let's look at our movements of this zombie. A basketball zombie is dribbling his head. Make up a story about what's going on with the graph. Okay, so we have this movement, and this movement. Okay, 3 different movements happening in this graph. So at 1, straight line, speed time graph, constant speed, because it's not on the x-axis. So 1 is constant speed. 2 is moving down. The line up here moving down was C, and C we said that they're slowing down. So 2, slowing down. And 3, a straight line again, not on the x-axis, so more constant speed. Okay, so that is our notes for today. Remember, this back page is all about speed time graphs. This front page is all about distance time graphs. And if you look at your assignment for today, it's going to be about distance time graphs, so make sure that you're using this information on 7.5A assignment.